Welcome to the Deep Dive, the show where we take a stack of sources, articles, and research and really dig into them to pull out the most important insights. We want to give you that shortcut to being genuinely well-informed. And today, wow, we're plunging into the mind of someone whose name is basically shorthand for genius, Albert Einstein.
Absolutely a towering figure.
Right. When you hear Einstein, you probably picture, the wild hair, maybe that famous photo with his tongue out.
Mm-hmm. Or EMC.
Exactly, EMCEI. But, and this is what we want to explore, do we really know the man behind all that? Behind the image, the equations, what was actually driving him? What were his struggles, his big questions?
At the core of it, isn't it? Moving beyond the icon.
Yeah. So our deep dive today, it's all about exploring his core identity, some really unexpected influences that shaped him, and these profound philosophical quests he was on. We're drawing heavily from this unique biographical memoir, which gives us some incredible glimpses into his inner world.
It really does.
Well,
offers a different perspective.
And you should expect some surprises. We'll look at how his so-called failures might have actually fueled his genius, his very unique definition of what a scientist even is, and these deep personal battles he fought, sometimes even with his own groundbreaking discoveries. So let's really unpack the legend. Let's get into Albert Einstein.
Okay, so it's fascinating, isn't it? We tend to think of geniuses as just appearing, fully formed, answers ready from day one.
Like these spring out of nowhere, yeah.
But Einstein's journey, from what our sources say, was, well, anything but a straight line. Before he became Einstein, the legend, what was his early life like? What kind of person was he really at his core?
That's absolutely the right place to start. So the basics. Albert Einstein, born March 14th, 1879, Ulm, Germany. Lived through some incredibly turbulent times, world wars, scientific revolution.
Yeah, huge period of change. Massive. He eventually became an American citizen 1936, I believe, after moving to Princeton, New Jersey. That's where he passed away in 1955. But like you said, it's the journey between those dates. That's where the story gets really interesting. It really challenges our ideas about what genius looks like.
How so? What was unconventional about it?
Well, for starters, his early education, it was rough, to put it mildly. The biographical accounts show he had significant difficulties in secondary school. He wasn't just struggling, he was actively antagonizing his teachers.
Really? Antagonizing them?
Yeah. He apparently found their methods incredibly stifling. He described it as them trying to stuff knowledge down his throat. He just rebelled against that rote learning approach. So definitely not a harmonious student-teacher relationship there.
Wow. So he wasn't the star pupil, not even close. That really cuts against the grain of the child prodigy image we sometimes have.
Completely. It makes you wonder, doesn't it, about the limits of traditional education, especially for a mind like his. Does genius need a different kind of environment to flourish?
It certainly suggests that maybe conventional academic success isn't the only route, or even the best one, for certain kinds of nines. Was there a point where things changed for him educationally?
There was a really important turning point, actually. He was sent to a special school in Aarau, Switzerland. And this place was different. Unlike the rigid German system he'd been in, Aarau allowed him to work more hands-on.
Hands-on, like labs and experiments.
Exactly. With mechanical devices, magnets, not just textbooks and lectures. And this kind of learning, this direct engagement with the physical world, it just clicked for him. It fascinated him. He felt like he could finally grow there, intellectually and personally.
Ah, so that practical exploratory side was key. Not just absorbing facts, but interacting.
Precisely. It highlights that learning, for him anyway, wasn't passive. It was active discovery, which is crucial for understanding how his mind worked.
Okay, so that sounds promising.
Uh-huh.
Did this new freedom then translate into, soaring grades when he got to university? What was his record like at the Zurich Polytechnicum?
You'd think so, wouldn't you? But surprisingly, no, not really. Not in the traditional sense. His university record, well, one rector looking back called it quite unpromising.
Unpromising. Even after Aarau.
Even after Aarau. He was apparently next to the bottom student in his class. And in the lab, where you might expect a future physicist to shine, he was always behind.
Always behind. How is that possible?
He just didn't like the formal structure. Hated lectures, hated exams, much preferred to read on his own, grapple with ideas in his own way. Even his professor, Hermann Minkowski.
Minkowski, wasn't he important for relativity later?
Hugely important. He developed the mathematical framework for space-time. But back then, Minkowski was apparently quite turned off by Einstein the student. Called him a lazy dog because he skipped lectures.
A lazy dog. That's incredible.
It really is. Minkowski definitely didn't see the future Nobel laureate in that student. It just forces you to ask, how on earth did someone with that kind of academic background, someone who bucked the system so much, become the Albert Einstein, the absolute symbol of genius?
Yeah, that is the big question. It suggests his real drive, his motivation, must have come from somewhere deeper, somewhere beyond just academic achievement.
Exactly. And that leads us to what was really pushing him.
Right, and this is where, for me, it gets incredibly fascinating. You mentioned his path wasn't linear. He wasn't just climbing the standard scientific ladder. Our sources emphasize that even his biggest breakthroughs, like relativity, he saw them as just steps along the way. Intermediate ridges was the phrase used.
That's right, not the final destination.
So what was the final destination? What was that Everest peak he was constantly striving for?
It was huge, almost spiritual in a way. His ultimate goal, the thing that really captured his attention his whole life, was nothing less than trying to uncover the secret of existence.
The secret of existence.
Yeah. And to find a completely harmonious structure underlying the entire universe. He wasn't just solving physics problems. He was on this deep philosophical quest for unity, for order, for the fundamental blueprint of reality.
That's profound. Did he talk about this explicitly?
Oh, absolutely. It comes through so clearly in his writings. He said things like, out yonder lies this huge world which exists independently of us human beings and which stands before us like a great eternal riddle.
A riddle to be solved.
Exactly. And maybe his most famous quote reflecting this is, the most incomprehensible thing about the world is that it is comprehensible.
Think about that. The mystery isn't that the universe is complex, but that we can even begin to understand it.
Precisely. It shows this incredible optimism in human reason. He deeply believed, and he wrote this, all of these endeavors are based on the belief that existence should have a completely harmonious structure. He felt we shouldn't let go of that wonderful belief, even when things seem chaotic.
That's such an audacious, hopeful way to approach science. It wasn't just about finding an answer, but finding the right, elegant, harmonious answer. How did that philosophical drive actually shape his scientific method, though? Did it make him approach problems differently?
Absolutely. It fundamentally shaped his approach. If you start with the conviction that the universe must be harmonious and simple at its core, you're not going to be satisfied with messy, complicated, arbitrary explanations.
You're looking for the underlying elegant.
Exactly, which is precisely what he found in special relativity, unifying space and time, or general relativity, unifying gravity and geometry. This quest gave him this incredible dream and drive spirit, this bulldog tenacity, as the sources put it. He just wouldn't let go of a problem until he found that harmonious solution.
And he even had a unique take on what a scientist should be.
He did. He famously called a scientist an unscrupulous opportunist.
Unscrupulous, that sounds harsh.
He meant it in the sense of being willing to seize any idea, any tool, any pathway, no matter how unconventional, if it might lead closer to that fundamental truth, that harmonious structure. It wasn't about following established rules. It was about getting to the core of the riddle, whatever it took. It wasn't ego or fame driving him. It was the puzzle itself.
That makes sense. An opportunist for truth. And what about him as a person? Beyond the determined scientist, what was he like? The stereotype is often the aloof genius.
Yeah, but the memoir paints a much warmer picture. It talks about his warmth, his considerateness, his deep thoughtfulness. He had this unique way of seeing the world as one harmonious and someday understandable whole, and he saw all of humanity as being in this together, feeling our way forward through the darkness together.
That's a beautiful image, a sense of shared struggle and discovery.
It really is. It shows a deep empathy, a connection to others on this quest. He wasn't isolated in his thinking. He saw it as a collective human endeavor.
So he wasn't just immersed in equations. He was deeply connected to humanity's place within that grand harmonious structure he was seeking. Did his way of communicating reflect that desire for shared understanding?
It seems so. People noted his communication style was remarkably clear, often slow, almost deliberate, as if ensuring his profound ideas could be grasped. He was spontaneous, serious when needed, but apparently always had this distinctive touch of humor as well.
So this picture emerges, an unconventional learner, driven by this huge philosophical quest for harmony, tenacious, opportunistic in his thinking, but also warm, thoughtful, articulate. That really sets the stage for understanding where his breakthroughs came from, doesn't it?
It absolutely does. It shows the complex human being behind the scientific icon, ready to tackle the universe's riddles.
Okay, so we have this picture of Einstein driven by this immense goal uncovering the secret of existence. But, having a grand vision is one thing. Actually doing the science, especially with that less than stellar academic record we talked about.
Yeah.
How did he bridge that gap?
Right. How do you go from philosophical quest to groundbreaking physics?
Yeah. And it turns out the place where he really seemed to forge the tools he needed was, well, completely unexpected. Almost mundane, really.
You're talking about the patent office?
Exactly. The Swiss patent office in Bern. This job he had, his first job apparently, from 1902 to 1909.
Yeah.
7 years.
And it's one of the most fascinating, maybe even crucial parts of his early story. At the time, a lot of people apparently thought it was no proper job at all for someone with his brains, especially given his university background. But it was the best he could get. And it turned out to be this incredible crucible for his thinking.
A crucible, I like that. So the future architect of relativity, sorting through patent applications.
Yeah.
What was the day-to-day like? And how on earth did that shape his genius?
Well, think of it as this intense daily discipline in distillation, in clarity. Every day he had a quota of patent applications to get through. And back then, crucially, each application came with a working model.
A physical model, not just drawings.
A physical model. So he wasn't just reading descriptions, he was looking at actual devices, often complex, sometimes probably quite badly designed or explained. And his boss there, described as a kind, strict, and wise man, gave him very clear instruction. Explain very briefly, if possible, in a single sentence, why this invention would work or why it wouldn't. Should the patent be granted or denied? Just get straight to the point.
Wow. One sentence for potentially complex inventions.
Exactly. Imagine doing that day after day. He was forced, relentlessly, to distill the central lesson out of objects of the greatest variety, to cut through all the noise, all the superficial details, and find the core principle. Was there a genuine innovation here? Or was it just rehashing old ideas? Did it violate basic physical laws?
So it wasn't just bureaucracy. It was like this intense practical masterclass in critical thinking and identifying fundamental principles.
Precisely. The source material even asks, rhetorically, who knows a more marvelous way to acquire a sense of what physics is and how it works? It trained him over and over to sift the essential from the non-essential. It was like intellectual weightlifting for spotting the core idea.
It's like he was the world's smartest quality control inspector, forced to find the absolute essence of how things work. That's amazing. And does this connect to his writing style? Because his papers are famously clear, very pithy.
There's a direct link made, yes. He himself said his boss was more severe than my father, taught me to express myself correctly. That daily demand for absolute brevity and clarity honed his unsurpassed power of expression.
So the patent office didn't just sharpen his thinking, it sharpened his words too.
It seems so. The memoir even compares his writing to Galileo's, pointing out that Galileo was studied in Italy not just for science, but for the power and clarity of his prose. It suggests Einstein had that same ability to make a telling point in the pithiest way. That skill seems directly forged in the patent office.
It's just incredible to think this seemingly ordinary job was so fundamental. Okay, so let's make the big connection. Can we really trace a line from this daily practice of distillation, this focus on essentials, to his earth-shattering papers in the miracle year of 1905?
Yeah.
He wrote those while at the patent office, right?
Yeah, absolutely he did. And the connection seems direct and powerful. Think about the skills he was honing: clarity, simplicity, getting to the core principle. And then look at the 1905 papers. First, there's Brownian motion. Before him, the actual existence of atoms was still kind of debated, right?
Still up in the air, yeah.
So Einstein looked at this seemingly random jiggling of pollen grains suspended in water. He connected it to his lifelong concern with statistical mechanics, the worries about underlying randomness. And he showed mathematically that this jiggling was exactly what you'd expect if tiny, invisible atoms were constantly bumping into the pollen grains.
So he proved atoms were real just by analyzing this jiggly motion.
Essentially, yes. He turned a theoretical worry into concrete quantitative evidence for atoms, a fundamental insight distilled from observing this seemingly chaotic phenomenon.
Okay, paper number 1. What else came out that year?
Second, the photoelectric effect. This is the one he eventually won the Nobel Prize for, actually. Here, he proposed something utterly radical at the time. That light energy doesn't travel as a continuous wave, as everyone thought. Instead, it comes in these discrete packets, these quanta of energy, arriving accidental in time and space.
Like tiny bullets of light.
Kind of, yeah. A stream of tiny energy bullets. This simple, revolutionary idea, light as particles, or photons as we now call them, was a foundational piece of quantum theory. Again, a simple core idea challenging centuries of thinking.
Okay, atoms proven, light quanta proposed, and then the big one.
And then the big one, special relativity. This is where he fundamentally rewrote our understanding of space and time. He showed that space by itself and time by itself are doomed to fade away into mere shadows.
Meaning they aren't absolute.
Exactly. They aren't fixed, separate things. Instead, they're interwoven into a single flexible fabric space-time. And out of this came the most famous equation in history, or EMC say, showing the equivalence of mass and energy.
Just world-changing stuff, all while working as a patent clerk.
Right. Which brings us back to the question, why him? Why did this relatively unknown patent clerk make these enormous leaps when established professors with all the resources didn't?
Yeah, what was his edge?
The argument, and it's compelling, is rooted right there in his job. Would it not have been a greater miracle if anyone but a patent office clerk had discovered relativity? Who else was spending every single day honing the skill of extracting the simple central point from confusing, complex clutter?
So his job trained him to see the simplicity others missed in the clutter of electromagnetism.
Precisely. It wasn't about being the best mathematician. David Hilbert, a top mathematician of the time, supposedly joked, "Every boy in the streets of our mathematical Göttingen understands more about four-dimensional geometry than Einstein."
Wow, high praise.
Well, it highlights the point, Hilbert continued. Yet despite that, Einstein did the work and not the mathematicians. Einstein's genius wasn't necessarily in the complex math itself, but in his unique, patent office-honed ability to see the simple, fundamental physical principle that everyone else was overlooking. He could cut through the noise.
Okay, so the patent office was this unexpected forge. But then he moves on eventually to Berlin, right? Director of the Kaiser Wilhelm Institute for Physics. This is where his genius really takes flight on a grander scale.
Yes. Berlin was a period of intense creativity for him.
And if special relativity in 1905 was, say, the first major peak he climbed, our sources really point to general relativity as his absolute masterpiece, his greatest triumph.
Many would agree, yes. General relativity, which he completed in 1915, was a different kind of leap altogether. It wasn't just refining existing ideas, it was constructing a whole new framework for understanding gravity and the universe itself.
And it apparently started with a flash of insight, something about a falling painter.
That's the famous story, yes. He called it the happiest thought of my life. It supposedly happened around 1908. He imagined a house painter falling from a roof, hopefully unhurt, and realized that during the fall, the painter would feel weightless.
Like an astronaut in orbit.
Exactly. And the seemingly simple observation sparked a revolutionary idea. Maybe gravity, as we experience it, isn't a force pulling things down at all. Maybe, he thought, there's no such thing as gravitation, only free fall.
Whoa, okay, my brain just did a flip. No such thing as gravity. How does that even work? We feel it.
Right, it's counterintuitive. But what he meant was maybe the sensation of weight, the force we feel, is actually the result of something else preventing us from freely falling. What if free fall is the natural state, and gravity is really about the shape of space and time itself?
The shape of space and time, like bending it.
Precisely. By giving up gravitation as a traditional force, he actually won it back in a much more profound way, as a manifestation of a warp in the geometry of space.
Okay, explain the warp, like the bowling ball on the rubber sheet analogy.
That's the classic analogy, and it's a good one. Imagine space-time as that stretched rubber sheet. A massive object, like the sun, our bowling ball, creates a dip, a curve, in the sheet. Now, a smaller object, like the Earth, a marble rolling nearby, doesn't get pulled directly by the sun. Instead, it follows the curve in the sheet created by the sun.
So the Earth thinks it's going in a straight line, but space itself is curved, making it orbit.
That's the essence of it. As John Wheeler later summed it up beautifully, space tells matter how to move, and matter tells space how to curve. Massive objects warp space-time, and that warped space-time dictates how other objects move. That's what we perceive as gravity.
Mind blown. That's incredibly elegant. Was this purely his idea, or was he building on other work?
It was a masterful synthesis. He drew on two huge streams of thought from the 19th century. First, Bernhard Riemann's radical idea that geometry isn't just abstract math, but could actually be part of physics, that the geometry of space could be dynamic.
Okay, geometry is physics.
And second, Ernst Mach's arguments challenging the idea of absolute space, suggesting that things like inertia and acceleration only make sense relative to all the other masses scattered throughout the universe. Einstein somehow wove these deep, complex ideas together into this single, coherent, beautiful theory, general relativity.
And crucially, it wasn't just a beautiful theory, it made predictions, right?
Yeah.
Things that could actually be tested.
Absolutely critical. A theory is only as good as its testable predictions. And general relativity made some very specific, very dramatic ones. There were 3 famous early tests that really cemented its reputation and made Einstein a global celebrity.
What were they?
First, the bending of starlight by the sun's gravity. The theory predicted that light from distant stars passing near the sun should follow the curve in space-time, making the stars appear slightly shifted from their actual positions.
And they tested this during an eclipse.
Exactly. In 1919, Sir Arthur Eddington led expeditions to observe a total solar eclipse. The measurements confirmed Einstein's prediction almost perfectly. Huge news.
Wow. Okay, what else?
Second, a prediction about the redshift of light escaping a gravitational field. Light should lose a tiny bit of energy, shifting slightly towards the red end of the spectrum as it climbs out of a gravity well like the sun's. A much harder effect to measure, but eventually confirmed. And third, it perfectly explained a long-standing puzzle: the precession of Mercury's orbit. Mercury's elliptical orbit around the sun slowly rotates over time in a way that Newtonian gravity couldn't fully account for. General relativity predicted the exact amount of this extra precession. It just worked.
So prediction after prediction confirmed. That must have been incredible.
It was revolutionary. And the insights kept coming. General relativity showed that the motion of objects isn't governed by some separate law of gravity, but emerges naturally from the geometry of space-time itself. It also predicted that this geometry could ripple, that gravitational events could send out waves of distortion traveling through space at the speed of light.
Gravitational waves, something we've only recently directly detected, right?
Exactly. The concept of gravitational radiation carrying energy came right out of his theory. We had strong indirect evidence from observing neutron stars spiraling together, announced back in 1978, which won a Nobel Prize. But the direct detection by LIGO in 2015, hearing the chirp of black holes merging, that was a monumental confirmation a century after the theory.
And black holes themselves, another prediction.
Yes, the theory naturally predicted the possibility of gravitationally collapsed objects, regions where gravity is so intense, warping space-time so severely that nothing, not even light, can escape. Black holes.
Which we now have actual pictures of, well, they're silhouette anyway.
Right. We have compelling evidence for them across a huge range of sizes. Stellar mass black holes, maybe 10 times the mass of our sun, found in systems like Cygnus X1, intermediate ones in star clusters, and the supermassive monsters at the hearts of galaxies like the 4 million solar mass one in our own Milky Way, or that incredible 5 billion solar mass behemoth in galaxy M87 that the Event Horizon Telescope imaged. General relativity provides the rulebook for understanding these extreme cosmic objects.
So general relativity wasn't just about tweaking Newton. It fundamentally rewrote the rules of the cosmos, from bending light to black holes and gravitational waves. But didn't it also predict something about the universe as a whole that Einstein himself initially fought against?
Ah, yes, you're leading into that fascinating story, the biggest blunder.
Yeah, tell us about that. He applied his own theory to the whole universe.
He did, just 2 years after finishing GR in 1917. He tried to use his equations to describe the entire cosmos, and what the equations told him was, well, deeply surprising and unsettling to him. They predicted a dynamic universe.
Dynamic, meaning moving, not static.
Exactly. The math strongly suggested the universe couldn't just be sitting there, eternally unchanging, which was the standard view at the time. It had to be either expanding or contracting. And if you ran the clock backwards, it implied, well, a beginning, a point of incredibly high density and temperature.
The Big Bang, essentially. His theory predicted the Big Bang.
It pointed squarely in that direction, yes. But Einstein? He couldn't accept it. It clashed violently with his philosophical belief in a static, eternal universe.
So he resisted his own theory's conclusion. How?
First, he tried to find flaws in the work of others, like Alexander Friedmann, a Russian mathematician who also found expanding solutions. Einstein initially published a note claiming Friedmann's math was wrong, but quickly had to retract it. Friedmann was right.
Okay, so the math held up. Then what?
Then he tried to see if he could tweak his own beautiful theory of general relativity, but there was no natural way to change it to allow a static universe without making it ugly or inconsistent. So, as a last resort, he kind of cheated.
Cheated. How?
He introduced an extra term into his equations, completely ad hoc, a cosmological term, or cosmological constant. Its only purpose was to counteract gravity on cosmic scales and force the universe to be static to match his preconception, a fudge factor, basically.
And this is what he later called his biggest blunder.
That's the one. Because about a decade later, in 1929, the astronomer Edwin Hubble, using the big telescope at Mount Wilson, presented really convincing evidence. By looking at the light from distant galaxies, he showed they were all moving away from us, and the farther away they were, the faster they were receding. The universe was expanding.
Just like Einstein's original equations had predicted.
Exactly. When Einstein visited Hubble and saw the evidence, he finally accepted it and famously called that cosmological constant, that fudge factor he'd put in, his biggest blunder. It's a great story of intellectual honesty, admitting he was wrong, but we still give him credit for creating the theory that did predict the expansion, this incredible phenomenon, even if he initially resisted it.
But why did he resist it so strongly? It seems like his deep philosophical beliefs were actually acting as blinders here, at least for a while. What was the root of that resistance?
It goes deep, and the memoir connects it directly to his philosophical hero, Baruch Spinoza.
Spinoza again, the 17th century philosopher.
Yes. Spinoza was excommunicated for his radical views, including denying the traditional idea of a creation event. Spinoza believed in an eternal, necessary, uncreated universe. And Einstein deeply identified with this view. He felt the universe should go on from everlasting to everlasting.
So the idea of a beginning, a Big Bang, just didn't fit that picture.
It really didn't. The concept of a before the Big Bang seemed nonsensical to him, where he might have wondered, could a clock sit that should tell the universe when to come into being? The notion of a specific creation moment clashed fundamentally with his Spinozan ideal of an eternal, deterministic cosmos. So his deepest philosophical convictions led him initially to try and suppress one of his own theory's most profound predictions. It's a powerful reminder that even for Einstein, deeply held beliefs could sometimes obscure the path revealed by the science itself.
Okay, this theme of Einstein's deeply held beliefs, particularly that Spinozan determinism, brings us to another major battle he fought. This one wasn't about the cosmos on the grand scale, but the very nature of reality at its smallest scales, the quantum world.
Right. And it's perhaps the most profound and in some ways tragic intellectual struggle of his later life. Because his deterministic worldview, inherited from Spinoza, ran headlong into the bizarre implications of quantum mechanics.
Can you remind us what that Spinozan determinism really meant to him?
It was fundamental to his outlook. Spinoza essentially argued that nothing in the universe is contingent, meaning nothing happens by chance. Everything is conditioned to exist and operate in a particular manner by the necessity of divine nature, by unbreakable cause and effect. Einstein embraced this fully. He believed the universe was like a perfect clockwork, utterly predictable if you knew all the initial conditions. No room for randomness, no dice playing God.
Right, a clockwork universe.
Yeah.
But then came quantum mechanics.
And here's the great irony. Einstein himself was one of the pioneers. His 1905 paper on the photoelectric effect, proposing light quanta, was a crucial early step into the quantum realm. He was among the very first to clearly recognize that the real world and the world of the quantum is a world of chance and unpredictability.
So he helped create the theory that would fundamentally challenge his own deepest beliefs about reality. That's incredible.
It's a central paradox of his scientific life. He opened the door to the quantum world, but he couldn't bring himself to fully walk through it and accept its weirdness.
And this led to his famous debates with Niels Bohr, right? This legendary scientific dialogue.
Exactly. The Bohr-Einstein dialogue is one of the great epics of 20th century science. For a while, in the early days of quantum theory, their work was almost complementary, like a duet, as the source puts it.
How so?
Well, Einstein's 1905 light quanta paper, then Bohr's 1913 model of the atom with electrons in specific energy states, emitting light quanta when they jumped between states. Then Einstein again in 1916, showing that even though light emission and absorption seemed governed by chance, they still followed statistical rules like detailed balance. They were both building blocks.
But then things diverged. When did the parting of ways happen?
The real break came around 1927. This was when Bohr and others, like Heisenberg, were formulating the Copenhagen interpretation of quantum mechanics, which included Bohr's concept of complementarity.
Complementarity. What did that mean, and why was it such a problem for Einstein?
Complementarity is a subtle but crucial idea. It basically says that quantum objects, like electrons, have certain properties that are complementary, meaning you can't precisely measure both at the same time. The classic example is position and momentum. The more precisely you measure an electron's position, the less precisely you can know its momentum, and vice versa.
So there's a fundamental limit to what we can know.
Yes. And Bohr argued this wasn't just a limitation of our measuring devices, it was a fundamental feature of reality at the quantum level. It prevented a detailed, classical, space-time description of what's happening during a quantum event. And crucially, it embraced inherent randomness and probability as fundamental.
And that clashed with Einstein's clockwork universe.
Violently. For Einstein, with his deterministic set from Spinoza, this was unacceptable. Probability for him should only arise from ignorance, from not knowing all the hidden variables. It couldn't be baked into the fundamental laws of nature. This is when he made his famous declaration: God does not play dice. He simply couldn't accept a reality based on chance.
It's fascinating that the man who introduced chance into quantum processes in 1916 spent the rest of his life arguing against its fundamental nature.
It's a profound tension. He believed there had to be a deeper, deterministic reality underlying the quantum probabilities. He spent decades trying to find flaws in quantum mechanics, arguing it was incomplete.
Now, it's easy to paint this as Einstein being stubborn, unable to accept the new physics he helped start, but the memoir suggests this disagreement was actually productive.
Incredibly productive. It emphasizes that this wasn't just grumpy old Einstein refusing to change. It was perhaps the greatest scientific debate ever. Never in recent centuries. A dialogue between two greater men over a longer period on a deeper issue at a higher level of colleagueship.
Wow. So how did Einstein's challenges actually help quantum theory?
Because his objections were brilliant, he devised incredibly clever thought experiments designed to expose what he saw as inconsistencies or paradoxes in quantum mechanics. He challenged the interpretation of the double-slit experiment, proposed ways to seemingly violate complementarity by weighing a photon, and developed the famous EPR paradox, the Einstein-Podolsky-Rosen thought experiment, highlighting what he called spooky action at a distance, to argue quantum mechanics must be incomplete.
Spooky action at a distance. Entanglement.
Exactly, quantum entanglement. And each time Einstein came up with one of these ingenious challenges, Bohr and his colleagues were forced to grapple with it, to refine their thinking, to clarify the interpretation. Einstein's relentless questioning forced Bohr to sharpen and strengthen Bohr's position.
So Bohr had to really define what quantum mechanics meant in response to Einstein.
Yes. A key outcome was Bohr introducing the term phenomenon. He argued that you can't really talk about what a quantum particle is doing before you measure it. A quantum phenomenon only becomes real, only exists in a definite state when it's brought to a close by an irreversible act of amplification, basically, when it's measured or observed, interacting with the macroscopic world.
Leading to that central, almost mystical-sounding idea.
No elementary phenomenon is a phenomenon until it is an observed phenomenon. Before observation, you just have probabilities, potentialities. The act of observing forces reality to choose, as it were.
So, ironically, Einstein's lifelong resistance, rooted in his deterministic philosophy, ended up playing a decisive role in solidifying and clarifying the very theory he rejected.
That's the argument, yes. His skepticism pushed quantum mechanics to become more robust, its foundations clearer. He never accepted it fully himself, believing it was incomplete, but his brilliant critiques were essential catalysts in its development and eventual widespread acceptance. It's a powerful lesson. Deep disagreement, when conducted respectfully between great minds, can actually propel science forward.
So we've seen Einstein, the revolutionary scientist, reshaping physics, grappling with the cosmos and the quantum. But he wasn't just locked away with his equations, was he? The sources make it clear he felt a strong connection to the wider world, a sense of responsibility.
Oh, absolutely. He felt a profound obligation, especially as a professor supported by the public, to speak out on what he called the higher values of all humanity. This wasn't just a side interest, it was integral to who he was.
And he had quite a platform, didn't he? He became globally famous.
Immensely famous. And he used that platform. The memoir describes him as having the character of an Old Testament prophet and possessing all of the eloquence to match. He knew how to make his voice heard.
An Old Testament prophet. That's quite an image. How did he approach using that voice?
He understood communication. He believed strongly that what is long is lost. Brevity was key. Pith and pungency were the points of his pronouncements. He aimed for concise, impactful statements that would resonate, create an audience, and hopefully spark change. These weren't just off-the-cuff remarks, they were deeply held convictions he wanted to share.
He clearly felt a duty to use his influence for good. What principles guided his efforts outside of science?
A core principle seems to have been this deep sense of gratitude and humility, a feeling of reciprocal obligation. He famously wrote, "100 times every day I remind myself that my inner and outer life are based on the labors of other men, living and dead, and that I must exert myself in order to give in the same measure as I have received and am still receiving."
Wow. That's a powerful daily reminder of interdependence.
Isn't it? And this wasn't just talk, it translated into action. He consistently advocated for social justice, for social responsibility. He strongly emphasized political systems that don't rely on coercion, believing people contribute most freely when not forced.
So he was wary of authoritarianism.
Very much so. He spoke out strongly against McCarthyism in the U.S., for example, defending intellectual freedom. And interestingly, he also showed admiration for social safety nets, like the social care systems Bismarck had set up in Germany, which provided for people in times of illness or need. It shows a real practical compassion.
And having lived through 2 world wars, his views on war and peace must have been deeply felt.
Profoundly. He repeatedly spoke out against the sheer wastefulness of war, the lost lives, the hatred it bred, the way it perverted values. He was a consistent voice for peace. But, and this is an important distinction the sources make, he wasn't an absolute pacifist in all circumstances. When it came down to a choice between war or freedom and justice, he chose freedom and justice. He believed some evils, like Nazi tyranny, had to be resisted, even by force if necessary.
Which explains his famous letter to President Roosevelt about the atomic bomb.
Exactly. Warning about the possibility of Germany developing an atomic bomb and urging the U.S. to start its own research wasn't an act of aggression, but a desperate measure born out of the fear of a greater evil triumphing. A terrible choice, but one he felt necessary for freedom and justice.
That adds a layer of complexity. And what about his connection to his Jewish heritage? He wasn't conventionally religious, but that identity was important to him.
Very important, yes. Although he famously declined the offer to become the first president of Israel, he felt unsuited to politics. He remained deeply committed to supporting the Jewish community, and particularly the Hebrew University in Jerusalem. He saw it as a vital center for Jewish intellectual life and worked tirelessly for its success.
Why was that heritage so meaningful to him?
He deeply valued certain aspects he associated with the Jewish tradition. He listed them as the pursuit of knowledge for its own sake, an almost fanatical love of justice, and the desire for personal independence. He said these features made him thank my stars that I belonged to it.
So knowledge, justice, independence, you can see how those values informed both his science and his public life.
Absolutely. It paints a picture of a truly integrated individual, not someone compartmentalizing his science from his ethics, but someone applying his powerful intellect and moral compass to the whole spectrum of human experience. He wasn't just in an ivory tower, he was deeply engaged with the world.
We've covered so much ground: the unconventional learner, the patent clerk forging clarity, the revolutionary theorist of relativity, the reluctant quantum pioneer, the determined philosopher, the engaged humanitarian. As we start to wrap up this deep dive, what stands out as Einstein's enduring legacy, especially thinking about his unfinished business, the quest he did complete? How does he still speak to us now?
Well, the image we get is of someone who worked with all his force to the very end. Even in his last days, the memoir describes his face as tired, clearly having given everything, but his spirit was still fighting for his causes, still striving.
Still climbing that Everest.
Still climbing. And he definitely left some significant unfinished business on the scientific front. His biggest quest in his later years was the search for a unified field theory, a single geometric framework that could describe all the forces of nature: gravity, electromagnetism, and ideally the nuclear forces too.
The ultimate unification. Did he make progress?
He dedicated decades to it, often working in relative isolation from the mainstream of physics, which was more focused on quantum theory. But ultimately, using the mathematical tools he had, his specific approaches came to nothing in his lifetime. He didn't find the unified theory he sought.
So a failure in that sense.
In terms of achieving his specific goal, then, yes. But the source material makes a crucial point. His dream of unification, his vision, is very much alive today. Modern physics, using new mathematical tools like gauge theory, a broader concept of geometry than Einstein had available, is making marvelous new progress towards that very dream. String theory, M theory, they're all part of that ongoing quest for unification that Einstein championed. His vision was just ahead of the available mathematics, perhaps.
So his aim was right, even if his methods didn't get him there then. What about the other big loose end, his rejection of quantum mechanics?
That's the other major piece. His deep-seated Spinozan determinism, as we discussed, ultimately stood in ruins when confronted with the probabilistic reality of the quantum world, a world he paradoxically helped uncover. He never reconciled himself to it, remaining convinced it was an incomplete description of a deeper deterministic reality.
So two big scientific quests left unfinished or unresolved in his own lifetime.
Yes. But despite that, his lasting contributions are immense and undeniable.
What would you say are the absolute core elements of his legacy?
First, general relativity. It remains the ideal for a physical theory, unsurpassed in its elegance and predictive power. It's the foundation of modern cosmology and our understanding of gravity. Second, that unique talent for finding the central point, for distilling simplicity from complexity, which he applied to every subject he touched. That way of thinking is timeless.
And maybe something even broader.
I think so. Perhaps his greatest legacy is that he did as much as any man who ever lived to make us face up to the central mysteries of this strange world. He constantly pushed humanity to ask the biggest questions about space, time, reality, existence itself. And that ultimate goal, that snowy peak he was always aiming for, a completely harmonious account of existence that light shines brighter than ever. It inspires scientists, and indeed all of us, to keep searching, keep questioning.
That really brings it back to us, doesn't it? How do we today carry forward that spirit, that relentless curiosity, that pursuit of fundamental understanding, especially when it gets difficult or when what we find challenges our own comfortable beliefs?
That's the enduring challenge and inspiration of Einstein, I think. The memoir concludes beautifully by saying that Einstein no longer belongs to any one country, any one group, any one age, but to all friends of the future. He doesn't even belong to himself anymore. He belongs to the world.
He belongs to the world.
Yeah. His life is this incredible testament to relentless inquiry, the sheer courage needed to challenge established thinking, even your own thinking, and the profound link between striving to understand the universe and living a life of purpose, engaged with humanity's struggles. He showed that seeking knowledge and seeking a better world are deeply intertwined.
What an incredible journey through the life and mind of Albert Einstein. It's so clear he was far more than just a physicist's caricature. A philosopher, a humanitarian, a relentless questioner right to the end. So here's something to think about. Einstein chased that completely harmonious account of existence, right? Even when his own discoveries, like the universe expanding or quantum chance, seemed to scream against his deepest beliefs in an internal, deterministic world. What does that mean for us? How do we cultivate that same spirit, that unscrupulous, opportunist curiosity, as he called it, in our own lives? How do we pursue understanding, even when the facts push against what we want to believe or what feels comfortable? How do we embrace the struggle for deeper knowledge, even when it leads to uncomfortable truths? That's our deep dive into the rich, complex world of Albert Einstein. We really hope it's given you a fresh perspective on this iconic figure, maybe spark some new questions for you to explore. Until next time, keep asking those big questions.